Okay, problem number one. If the measure of the supplement of angle A is 5 times the measure of the complement of angle A, what is the measure of angle A? So first thing I want to do is point out that there are 3 unknowns. We don't know the measure of angle A, so I'll call that x. I don't know the measure of the complement of angle A, so to find the complement, it has to be 2 angles that add to equal 90, so if you know one of the angles, you subtract that number from 90, and 90 minus x becomes the expression for the complement of angle A. And the supplement of angle A, 2 angles that add to equal 180, you subtract the given angle, angle A in this case, from 180 and you have the measure of the supplement. So I'll just shrink that down, move it over to the side. Now to solve the problem at hand. It says the measure of the supplement of angle A. I'll write that down. 180 minus x is equals 5 times the measure of the complement of A. 5 times the complement of angle A. So now I have an equation that I can solve by using, first of all, the distributive property. So that gives me 180 minus x equals 5 times 90, 450, minus 5x. Adding 5x to each side of the equation, we get 4x over here. So I'll copy down everything else. 180 plus 4x equals 450. We subtract 180 from each side of the equation. That gives us 4 times x equals 270. We divide each side by 4, and we have x equals 67.5. So that appears to be the answer. We answered what is the measure of angle A. We stated 67.5. But now we still have, or should, check the answer. So I'm just going to minimize some of this and checking the answer. A is 67.5, so the complement is 90 minus 67.5, so the complement is 22.5. That's the complement. And the supplement is 180 minus 67.5, which gives us 112.5. And now we check the answer. So if that's the supplement, it says the supplement is supposed to be 5 times the complement. If it checks out to be true, so we'll put a question mark there. If it tests out to be true, it has to be the correct answer. 5 times 22.5 is 112.5, and that obviously checks. 112.5 is 5 times the complement. Next problem. Now we want to use the angle addition postulate because we have 2 adjacent angles. Angle ABD is adjacent to angle DBC. So because they are adjacent and supplementary angles, that gives us our equation. The first angle, 5x plus 10, added with the angle next to it, has to total 180. So now we take that equation and simplify it. We have 6x plus 12 equals 180. We subtract 12 from each side of that equation. We get 6 times x equals 168. We divide each side by 6. X equals 6 goes into 16 twice with 4 left over. 6 goes into 48 8 times. We have x equals 28. So that answers the first question, 28. But to answer the next 2 questions, we plug in the value for x in each case. So we have 5 times 28 plus 10. 5 times 28 is equal to 140 plus 10. That angle is equal to 150. And the last angle is 28x plus 2, plugging that value in here. And now we have 28 plus 2 is equal to 30. This is how we check the answer. Okay, by asking 3 parts to the question instead of just saying solve for x, I'm forcing it to kind of check your answer automatically. Those two angles obviously add to equal 180, so if this angle on the left is 150 and this angle is 30, it obviously adds to equal 180, so therefore the answer checks. And we'll do one more problem. Again, using the angle addition postulate, we have the measure of angle ABC is given. That's adjacent to angle CBD, so therefore they should add to equal angle ABD. So we'll plug in the values into that equation or statement I just made. ABC, 3x minus 2, added with CBD, x plus 4. The two adjacent angles add to equal the angle formed by the exterior sides, which in this case is angle ABD. So we have an equation we now simplify and solve. So 3x plus 1x is equal to 4x. Negative 2 plus 4 is equal to plus 2 equals, using the distributive property, we have 2 times 3x is 6x, plus 2 times negative 34 is negative 68, plus the negative 68 or minus 68. Subtracting 4x from each side of the equation to continue, we have 2x minus 68 equals 2. Adding 68 to each side of the equation, we get 70 equals 2x. Divide each side by 2. We have x equals 35. So the way in which I set up the 4 questions, I'm basically asking you to check your answer. If x equals 35, then ABC is 3 times 35, 105, minus 2, which is 103. 35 plus 4 is equal to 39 for angle CBD. And 3 times 35 is 105. So we have 2 times, in parentheses, 105 minus 34. 105 minus 34 is equal to 71. 71 times the 2 out in front gives us 142 for the angle formed by the exterior sides. And notice now 103 plus 39 does add to equal 142. So that answer checks, or all of the answers check. And one more problem. If we have a bisector, that means the angles, or the ray is exactly in the middle of angle ADC. It forms 2 congruent angles. So if this angle is x minus 10, the angle on the other side has to be x minus 10. If the angle formed by the exterior sides is given as equaling 4 times x minus 20, the x minus 20 in parentheses, that gives us the angle addition postulate, which is ADB added with BDC should equal angle ADC. Or another way of doing the problem is to say the original angle, or the larger angle, ADC, is twice as big as either of the other two. That equation would also work. Or you could say the smaller angle, ADB, for example, is half of angle ADC. Any one of those 3 would work. They all give you the exact same answer, so we'll just stick with the first one. X plus x is 2x, minus 10 is minus 20, equals 4x minus 80 when you use the distributive property. Subtracting 2x from each side gives us negative 20 equals 2x minus 80. adding 80 to each side gives us 2x equals 60. You divide each side by 2, you get x equals 30. So that's the first answer. ADB, the next answer. 30 minus 10, which is 20. The next answer, in parentheses, we have 4 times, in parentheses, 30 minus 20. 30 minus 20 is equal to 10 times 4 equals 40. And notice it makes sense. The angle formed by the bisector is 20 degrees. The original angle, or the larger angle in this case, is 40 degrees. 20 is obviously exactly half of 40. Hope this helps. Good luck.